Hey everyone, and today I am going to be walking you through the differences and variants of the B series pistons and conrods. As you can see here, I have a piston and conrod. This piston and conrod in this example is from a B48E. And I'll get into the specifics of this in a sec, but this also applies to B58, B58TU, B48TU, B46, B46TU, B48, the Mini Cooper B48s, B38s if you really care about those, and the B48E, or B48A20T1 if you really care about it. All right, so we have in front of us a Gen 1 Mini Cooper B48 piston. Now, this is the 11 compression piston, which if you actually have a close look, you can see it's actually imprinted onto the top of the dome. With all the male pistons, it took me a little bit of time to actually clean all the, well, as best as I could clean the carbon off of the pistons so we could look at these. But we've got a male part number here, and we've got some male part numbers here, including a QR code. This was the only B40 piston I found that actually had a marking on it. Now, it's possible that the 11 compression ones, for whatever reason, had this stamp, but I couldn't find anything else aside from that. But I'm going to go over and we're going to talk about the piston design. So these pistons are a Marl Evotech design. These are actually some of the first generations of the Evotech design. This design does vary greatly from an N20, N55, S55. The biggest change, if you haven't noticed, I'll put it this way so we can try and see it clearly. The Evotech pistons used a trapezoidal design, whereas the N20, S55, etc. were more of a square setup, meaning that both sides of the piston skirts were identical. There was obviously a few changes, but you can pretty much guarantee N20, N55, B48s, they all have a skirt coating. Now this piston, you can't really see it because the chemicals I used to clean the carbon off has affected the coating, but this piston, you can see it. This is a B48E, but it doesn't matter. The coating is the same pretty much on all of them. This is a low friction coating. The purpose of this coating is to help with basically with start-stop operation, but the other big thing too is it provides a level of protection to the piston if there is at any point any low oil. So having damage like this, I mean, you call it damage, this is fine. The piston is still within spec and it is still going to be able to complete operation. The purpose of this coating is a protection barrier. So sure, you get rid of this barrier and then you have some scuffing or some sort of low oil or start-stop operation or whatever, then yes, you are starting to damage the piston, but this is designed to basically be that barrier of protection. So this wear mark is exactly what it's designed for. It's designed to protect the engine. So this is normal. It's not even that much, and it's the only piston out of the entire set that even had this on it. All right, so back to this piston. Now, the main thing that was quite important when it came to the design of the Evotech piston was it was one of the first Marl pistons to get a casted-in steel top ringland. So if you can see the top ring here, you see that discolored looking metal bar that sits above and below where my thumb is. That is a casted-in steel ringland protection groove, right? And the idea behind this basically is in a high boosted engine application, this allows the aluminium piston to be a bit stronger in the ringland area, the primary, this is the compression ring, the top ring, which is the one that takes all of the brunt. This actually allows the piston to take a bit of abuse, particularly from heat. And it will assist in ensuring that we minimize ringland fatigue, which, as everyone knows, is pretty common on the B48 Gen 1 pistons. When they do break, it's usually the ringland that lets go. Now, you might go, well, but why is it still breaking if we have this casted-in steel groove that's supposed to add strength to the piston? It's not a magic bullet. It helps versus without it. I mean, all the M20 pistons didn't have this. N55, S55, much the same. Oh, the S55 is actually, to be fair, it's a slightly different piston design. It did have it. But the S55 is out of the realm of this topic of conversation. The N55 and N20s didn't have the casted-in steel like this. They had a slight variation of a top ringland support section, but that is out of scope for today. So with regards to this piston, that's the first, I guess, improvement they made with the B series generation, right? Now, another thing too when it comes to piston strength is you've got your arches in here, right? And these all add into the strength of the overall piston. So you can see here we've got quite a bit of ribbing occurring, and that ribbing is to aid strength, particularly on the wrist pin section. Right, now the reason why they went with the trapezoidal is because you only really need material on the thrust surface. And when I say thrust, I'm referring to the side of the piston that is going to be under the most load on the downward stroke, on the power stroke, right? That's where you're going to need majority of your material, because if you can make a lighter piston, you can make a more efficient engine, right? So this side, which is the non-thrust side, is narrower, all right, by design, because they were basically trying to look at ways to remove as much weight from the piston without jeopardizing on the strength. Right, you've also got the trapezoidal shape, and the reason why is because when the piston is obviously, you know, like this, I'll put it like this for the camera, you're making a bit of a triangle, right, in here. You're making a triangle. So basically, you've got to look at it like the center point of the top of the triangle would be basically in line with the half of the piston, right, and the center of the piston. So all the forces pushing down on that piston are pushing on the tip of the triangle, and the triangle is then distributing its weight down its sides, and those down that side into the wrist pin, right? And you can see that here, because if you look in here, right, you've got a lot more room on the top side of that wrist pin surface, where the wrist pin would sit on that surface of the piston, than you do on the bottom, because the bottom, you don't need that strength. All the bottom is doing is basically just, it's basically just helping secure it to the conrod, because a lot of the force on a piston with the wrist pin is always going to be the top side. When the piston is pushing down, the top of the piston is pushing against the wrist pin, and the wrist pin is pushing against the conrod. When the conrod comes back up, it is the wrist pin pushing on the top of the piston. So you don't need a lot of strength in the bottom here, and there's not a lot of force. There is still a force on it, and they still have to have material, but they don't need as much as the top. And that's why you'll notice that trapezoidal, you know, you can see how there's more surface area here than there is on the bottom. So typically a lot of the Mini Cooper pistons were 11 compression. They pretty much all were, actually. They were pretty much all 11 compression. The JCWs were the only ones to get a 10.2 to 1 compression ratio, which is up over the N20 because it offered a 10 and an 11 compression ratio option. Obviously the 11 compressions on the N20 were for the 320i's, you know, the quote-unquote fuel-efficient, low-powered cars. Look, the 11 compression versus a 10 compression piston, they still have the same power potential, but the problem you have with an 11 compression piston is that it is so much more sensitive to things like detonation, right? Because you've physically increased the compression in that cylinder, you're compressing everything so much more than on a 10 to 1, 9.5 to 1, etc. So when it comes to being able to run big boost, good ignition timing, etc., you're pretty much limited to exotic fuels, meth, alcohol-based fuels like ethanol, because those fuels are pretty resistant to knock, detonation, whatever. When you run things like pump gas and you start turning the boost up, they become knock limited very quickly, and you start being able to max out those engines very, very quickly. And there was a problem, I guess, in the early days of the B48s and even the N20s. Granted, the 11 compression N20s were not sold in great magnitudes, rather, but with the 11 compression B48s, it was. And a lot of people didn't realize when tuning it, particularly customers, and I think BMW realized this when they released the TU B series engines. They moved away from 11 compression, not because it wasn't a smart decision. It was definitely a great way to make an efficient engine, and it was a great way to save on fuel economy. The problem was the global quality standard for fuel was not consistent. So you would get places, and I use a good example, Egypt. Fuel there, from my experience, majority, pretty much all of it, is terrible. It's pretty low grade compared to places like the US, right? It's not great. China fuel is not great either. Nevada, California, like the ACN areas, their fuel's not great. Look, it's got nothing to do really with the countries themselves. It's just the way that the fuel is refined and the quality standards that are in place in different parts of the world. It's just not the same. So as a result, you ended up with a lot of cars, even in stock format, particularly on the Mini Coopers, where they would end up cracking a ringland. The pistons would end up failing. Now, obviously, with the Mini Coopers particularly, it was because there was a defect in the piston design. There was a leakage. I think it was to do with the casting, from my understanding, around the ringland. It was right near the valve relief. Not sure if it was intake or exhaust, where, for whatever reason, the way that the castings were made, and it was only a certain amount of batches, I believe pretty much late 2014 into 2015, the cars had rectified majority of those problems, but the problem was that they sold a bunch of those cars in pretty much all of 2014 that had these problems. So Part number for part number, you'll notice there is a different part number on the pistons between parts of the B48 Minis and then obviously into the F Series. The F Series will align with the later model Mini Coopers. But you can see with the piston, we've got this design for the Gen 1s. Now, if we move on to our F Series counterpart of the Gen 1, we can look at any possible differences. So, and another thing I'll point out too is you can tell it's a cast piston because, well, it looks like a cast piston. So, I mean, if you look at this, you can tell it has a bit of a funny surface texture. Right? If you put your finger over it, it feels almost like you've made it out of clay, I guess. But if you look at it, you can tell because it's not super smooth. It's a dull color, right? Like compared to billet aluminium, it's a very dull color. You can see casting marks. I mean, that's a casting mark there. That groove, that line that you can see casting marks, all right? You can see obviously they've machined some parts of the piston, but you can also tell that this is a cast piston. I mean, you see this ribbing here. You can't get that on a forged piston, right? That's all from casting, all right? So it's pretty obvious to tell if you got a cast piston. Now, I don't know the metal composition of the Evotech Gen 1 pistons. Hyper-uratic piston typically will have a high silicon content in the casting. The name is interchangeable too with forged, but for the sake of cast, we're going to refer to cast. It will have a higher content of silicon in the piston. Now, when you add more silicon to a piston, it can make it harder and can reduce its expansion rate. It can make it stronger, but the problem though is that it's not always a silver bullet. When you add more, you make it a bit more brittle. So what that means is that it's less susceptible to things like detonation. And don't get me wrong, the forged alternative would be a 4032 forging. They're a high silicon content forged piston. They're hyper-eucratic, right? Hyper and hypo. Hypo means low silicon content. Like this one here would be hypo because it's got low silicon content. Now, with these, it's not to say that these don't have silicon in them. They just don't have as much as a manufactured cast piston that might have more silicon in them. So there's still a level of silicon. What level, I don't know the exact composition of these pistons, but it is worth mentioning that most manufactured pistons are a form of hyper-eucratic, but there are levels in the BMW world where some cast have more silicon than existing cast offerings, and there's an obvious reason for that without going into a forged piston. So definitely cast piston, not the greatest when it comes to strength. Now, when it comes to the Gen 1 F Series, really, besides the fact that you can tell these are two different compression ratios, now you can tell that this piston's had a bit of collision damage with something. You can see a little dot and the little dimples in the material. These are used pistons, not going to be in perfect condition, but I've taken the piston rings out of this one. These are two different compression ratios, but there is an obvious difference in the valve relief. You can see that this has a wider steel groove and a thinner bit of material in the valve relief than this here. This is, now granted, this is a 10.2 to 1 compression ratio, but you would think in theory, being on 11 compression, this should have more material again because they're trying to raise compression, but there is less. However, it has got more steel, casted steel in that ringland groove than this, but there is more material. So this could have been the change because maybe there was not enough parent material in the piston, and that's what was causing the aluminium to break away. And once the aluminium broke away, well, most of that steel was just ready to be eaten up. Outside of that obvious difference, right, is we've also got pretty much no differences that I can see visually when it comes to any of the other ringland areas. They all look the same. Much the same everywhere, pretty much. I mean, there's you can tell it's a revised casting because it's a slightly cleaner casting than this. This is a bit of a rougher casting. Now, these are the same pistons found in the B58. Obviously, the B58 came with an 11 compression piston setup. So, obviously not identical pistons, probably closer to this, but just the revised version of it. But they do share the same part numbers with the 11 compression B48s as well. Now, obviously, with the B58, you run less cylinder load per cylinder versus the B48, which is why typically you'll see issues in the B48s earlier than you would on a B58 when it comes to piston strength. But outside of that is here are some other differences between the two pistons. Now, the Gen 1 F-Series is on our left, Mini Cooper is on our right. 11 compression, again, like I said, you'd think more material, but if we have a look here, I'll try and show my torch in there. See that ribbing and the relief into the actual piston dome down into here. There's actually less material in that than this. Look at that. You can tell. You can really tell the differences of how much deeper this one is versus that, which means on the Gen 1 pistons, they've added more material into this part of the piston to give it strength, particularly because what is directly above this, a valve relief, right? Because that was obviously part of the problem with these pistons, where they were having issues with these pistons prematurely cracking. Now, probably would have been ideal to get an 11 compression B48 piston as well to compare against the two, but I don't think it's super necessary really anyway. It is obvious that there's some changes here, and as we get through the TU and the Gen and the B48E, you'll start to see where they're starting to move into the right direction. I mean, outside of that, the skirts are the same height. From top to bottom, they're the same height. All right, so from the top of the piston to the bottom of the skirt, it's 51.25 millimeters. Series Gen 1 B48 piston, it's the same. So there's not a lot of differences when it comes to our Gen 1 pistons, all right, between the two. There's obviously some significantly obvious changes really with just some of the design of the piston, even though they're both a Gen 1 EvoTech design. Yes, this has a higher compression, but point in case, when it comes to adding compression to a piston, the most common way is to just add material to the top of the dome. And if you look here, you can tell between the 10 and 11s, you can see there's obviously more of a drop on this ledge in this dome section than there is on this. Like I was saying, you know, it's pretty clear that this has got higher compression because they've added material to the dome. But it is interesting that if they're adding compression to the dome, it's not like the valves need any more relief. So it's pretty clear that that's probably one of the bigger changes they made between the two variations of the Gen 1 Mini Cooper, was adding more material in around here. Moving on, our Gen 1s are done. Actually, not quite. Moving on to our wrist pins for the Gen 1. A pretty basic, pretty standard setup wrist pin. Now this wrist pin has got a fair bit of damage to it because the piston and rod was left sitting out in the weather where I acquired it from. So there's not a lot of differences between the wrist pins. They're identical wrist pins. Pretty much identical anyway. So what I will do though is I'll just grab a measurement for you so you can see what the diameter is. 22 millimeters diameter. Now you'll notice they've all got a bit of a tapered design on here. That's to save weight, help save weight. Just given where the loads are on this. I mean, you can pretty much see where the loads are on this, where the Conrod sits and where it sits inside the piston. So that's the wrist pins. Nothing super special about them. I'm not sure what material they're made. I'm not sure what material they're made out of. Conrods. The Conrods are the same. The Conrods are the same in the generations. Now these rods have a bit of rust on them, so don't think too much about it. Now, I'll talk a bit more about the Conrods at the end because there is some specific stuff about this, but Conrods are the same. They've both got a brass bushing impregnated into the top of the small end. They're a standard IROX drop forged Conrod at a BMW. You can see, you know, they've got these little designs here for the bearings to sit in. Nothing super special. They use the same bolts as an M54, an N20, N55, S55 Conrod. So same bolts, right? From the M54 all the way to the B48. Pretty much every engine in that generation uses the same rod bolts. So all those people out there in the N20 world being like, oh, I'm going to upgrade the rod bolts because it's going to make the Conrod stronger. No, really the weakness with that rod was the rod itself. It's a cast rod, poorly designed setup. Right, now we move on to Gen 2 B48, B58s, right, B46 TU. We have a piston and we have a wrist pin. Now, yes, the top of the piston doesn't look pretty. It's because I tried to clean it. The chemicals left this weird glaze on it on this piston, but only for some weird reason. So wire brushed it off just to make it look a little bit more visible, right? Still got the same male part number there. It's got a male part number here. Besides that, this is a 10.2 to 1 compression piston, so same as the TU engines, right? We kind of come down into here. You'll notice that in here, unlike our revised Gen 1 Mini Coopers that added more material in there, the Gen 2s have removed material here. Now, this is an Evotech 2, right? Number 2. Not an Evotech 1, Evotech 2. Big differences, apparently, in what they could achieve. Now, they've revised the amount of material they've removed from the non-thrust side of the skirt. They've bumped up a bit of material in here. They revised slightly the angles that in which this triangle trapezoidal shape is set up. That's to help add strength. They've revised the casting. It's a better casting process. It's got a better metal composition as well over the Gen 1s from what their document says. We've still got the same general design though. It's still casting. It's still got our ribbing support here. We've still got our ribbing in here. We have a revised casted steel ringland for the top of the piston. You can see that there's not a lot of material here by the valve relief, but overall the design is quite revised. And I mean, we've managed to test these pistons up to 500 horsepower on a B48. The B58s have already proven themselves to 900 horsepower on a stock Gen 2 piston. They are phenomenal over Gen 1. I mean, if we pull out this 10.2 to 1 compressive piston compared to a Gen 2 and we have a look over them, I mean, you can see clear differences in the casting process. I mean, look here, just look at the shape right around here where the wrist pin sits. Look at that, it's nice and refined. We've got round edges here, right, versus this one here, which is a little bit more rougher. We do have a bit more material added here around here, but I think, you know, it's more about where the material is and how smart they are with it, right? So you can definitely tell too with look at the design of this piston. Look, we've got this weird, not so much weird, but this really nice curvature in terms of our rib on the skirt here. Whereas this is a lot more flat, like it's just flat. There's no real raised lip here, raised rib, right? You can see here the way that comes out. I mean, you can clearly see, I mean, that's the thrust side here on this piston, and for whatever reason, I mean, you can probably see the differences a little bit more here, right? See if I can balance these two together. This is your thrust surface on the Gen 2 piston, right? You can see up here they've added more material at the top and then they sort of curve down and around. So the skirt on the thrust side is stronger on a Gen 2, whereas with the Gen 1s, they've done the reverse. They've reduced material up here and then added it down there. It's a bit of a weird reverse, whereas here they've sort of just done it from the top, and that makes a bit more sense because you're adding in more structural integrity to the ringland and the side of the piston up here. This is all going to take more force, right? This whole section is going to take more force, particularly at the top, close to our compression zone, than the bottom of the piston ever will. So it makes sense that they've done that. If we flick over now to the non-thrust side, I'll just pick this up and put this here, and we'll see if they'll balance together. Hopefully they will. They won't. You can see they've made changes here as well. They've added material at the top, they've removed a little bit of it here, and then they've added more at the bottom, right? Whereas this is a lot more of a straight design. It's just sort of like one size fits all, send it or forget it sort of mentality. So they have definitely changed the design. They've definitely improved it. Look, this piston, the composition of it, the casting technology behind it, it's a phenomenally better piston. I mean, you can tell, just looking at the castings, you can tell how much of an improvement this casting is and the design changes that they have made, right? I mean, even if we look at the top of the domes, right, you can see that overall, they're much the same dome because they didn't really change a lot of they really didn't change anything when it came to the design of the combustion chamber, but just the way that the material has been casted and finished and cleaned up, they really have improved on this piston, particularly with the composition of the piston. It has got an improved piston composition. The rings are much the same when it comes to the ring materials used. They are much the same as the Gen 1s, so we're not really going to focus too much there. Our wrist pins, they're the same wrist pin. They're the same wrist pin between the Gen 1s and the Gen 2s. No difference there. Our Conrods. Our Conrods are the same. They have not changed the Conrod at all between the Gen 1s and the Gen 2s. So then, no change there. moving on now to our lucky B48E. Now, BMW have made some changes with this piston particularly, and it is the only B series engine to end up with this piston. The B48E is closer to an S58 in terms of the fact that it's more of an M engine than the B48TU ever was. It's got a bigger and juicier crankshaft. It's obviously a forged crankshaft like the B48s. It's got changes in the rod design, which we'll go into in a little bit further because I want to talk about that. The pistons, though, there are differences. Now, the marketing material would have everyone believe these are upgraded pistons. And upgraded pistons usually translates to a forged piston. However, as we've found out, it's not a forged piston. The S58 is the only turbo BMW from the F and G series that got forged pistons. The S55 had a high silicon content cast piston. They were definitely an upgrade over the N55 and N20 pistons, that's for sure, but they were a cast piston. Right? There are some people that believe they were forged factory. No, they were a cast piston, but they had high silicon content, which made them close to, I guess you could say, a casted version of a 4032 piston. So they're definitely stronger. The same with these, high silicon content, and you can sort of tell in the compositional texture, I guess you could say, of these pistons, there is a slight coloration difference, and the casting again has been improved. There are massive improvements to the casting between the two pistons. And there's also material added in certain places as well because they've lowered compression, so they sort of needed to. So as I was saying, when you go and lower in compression or add compression, usually you're adding or removing material from the dome, okay? In these pistons, they've removed more material from the dome than they have on the 10.2s. This is a 9.5 to 1 compression piston. Now, higher silicon content, and the reason why is because this car comes out of the factory with 25 PSI untapped boost, right? Whereas this comes out of the factory with around 17, 16 PSI, give or take, depending on the model that it is. They're different pistons. Now, you might notice, just sitting the two pistons here, oh, gee, that piston's sitting a bit higher than that bit. That's weird, that's funny. Let's turn them over. The deck height is the same on the engines. So what they've actually done, because they have reduced the compression, they've basically moved not everything, but obviously the physical location of the wrist pin, but they've moved everything up. And the reason why they've done that is obviously because when they remove material from the top, you don't want to jeopardize any of the strength in the piston. So you have to add material on the underside effectively to ensure that your thickness in the dome of the piston maintains the same regardless of compression. So the skirts are naturally higher than the skirts on the 10.2 to 1 compression pistons. So I've noticed something whilst I was sitting there editing away at the video. B48E Conrod. B48, B58 Conrod. The center to center in this rod is different. And it makes sense because before, when I was looking at the piston for the B48E and the B48TU, I noticed and I pointed out it looks like the skirt is longer. And whilst, yes, they've obviously added the B48E piston, they've added material on the underside up to compensate for the fact they've removed, nearly dropped the piston. They've removed material from the dome to reduce compression. What I didn't realize until I was literally listening to myself speak was that the conrod and the wrist pin location has changed. And it makes sense because when we looked at this on the table, it makes sense. When we looked at this on the table, we noticed when they sat upright like this, let's see if I can get it to do it, the dome was sitting a little bit more proud on the B48E to have the skirts align, which meant the wrist pin location was different as well. And I checked, the B48E Conrod uses 146 millimeter center to center, whereas the B48 and B58s use 148 millimeter. Bit of a difference. Now, that doesn't mean like the stroke or anything is off because it's still a 82 mil bore. I even double checked that to be sure. Still an 82 mil bore. It's still a 2 liter. But it does mean that it wouldn't be as simple as putting these rods, if you wanted to, for whatever weird and strange reason, into a normal B48 because you would need the associated change in piston. Otherwise, you'd have an issue with the piston's deck height position relative to the conrod's length. So, interesting fact. It's probably another reason why they changed the Conrod. Now, we go into it. These are also an Evotech 2 design piston, so there's not a lot of differences between the two in terms of any fancy changes. It's really just they're a 9.5:1. They are a higher silicon content piston than these, purely because of the abuse they're under, and you can sort of notice that because it's got a bit more of a shinier appearance than the TU piston. But also you'll notice too, when it comes to the strength and differences like that, we're back to the Gen 1 changes where they've added in more material in our valve relief areas. They've added in a lot more material in here. They've added more material here, and the cross section of this is a lot wider too than the TU piston. So obvious strength improvement there, and the ribbing and just the cross section of this area here. I'll just get these to make sure they're on the same page. We've got our thrust side, our non-thrust, and non-thrust. On the B48E piston, they've added more material in our exhaust relief area than our intake, but that sort of makes sense given they've removed a bit of material here, so I would assume they've done that to sort of try and strengthen the piston. But on the TU engines, they haven't done that. They've mirrored these reliefs in terms of depth. They're basically mirrored. So when it comes to the B48E, there's definitely a bit more strength in here on the reliefs, on the non-thrust side than the thrust side. In terms of overall design changes, I don't see a lot. There's obviously, I don't know if you can tell, but there's more material here, like as in depth of the material, than there is here. There's more of a relief on this part of the piston itself. Now, granted, like I said, lowering compression, they're pretty much moving the bottom of the piston further out, but to retain the strength of the top of the piston, the dome of the piston, maintain that same thickness as a 10.2. But there is overall considerations when it comes to thickness of certain parts of the piston compared to a TU piston. I mean, you can even see it here, right? We've got a slightly thinner casted steel ringland with more material in the valve relief here than the TU. Less material here, but more of a steel ringland, which is actually very similar to the Gen 1 Mini Coopers in regards to how that was set up. Again, not particularly sure why. They've run less, but you can also tell there's a slight difference in the type of casting. Just the material is clearly different in between these two pistons. Now again, this is designed, this piston, to take high boost because the car comes with high boost from factory. So there are some definite differences with this piston over this piston. Now, on to the real other difference. This is a wrist pin from a B48E, and this is a wrist pin from a B48TU and a B48 Gen 1. Notice anything different? Darker color, shinier color. The reason why is because on these wrist pins, they have added a coating. And they added the coating because on the Conrods, they got rid of the pressed brass bushing in the small end. So the benefit is to add a coating to the wrist pin to allow the Conrod to effectively be able to operate without the use of a brass bushing. Big revolutionary step. And in terms of the diameter, they're the same diameter, 22 millimeters. Yeah, we're just going to switch to the cam because the GoPro keeps overheating. Anyway, you get to deal with my ugly mug. All right. B48 Conrod. B48 E Conrod. B48, B58 Conrod, B48 TU, B46 TU, B58 TU Conrod. Right? These things, my camera doesn't cut it out. These Conrods have been able to withstand up to 1,300 Newton meters in a B58, and we've seen 800 Newton meters in a B48. Now, for those of you that only speak pound foot, that's 997 to 1,000 foot pound, give or take, and it's around about almost 600 pound foot, if my conversion math is correct. That's cooked. That's a factory Conrod. That is cooked. Almost identical, if not the same, as what's used in the diesel B57s, which obviously make a lot of torque factory, but I couldn't find a part number correlation, but it could also just be real OEM. to make that much torque on a factory Conrod is cooked. It's great, but it's cooked. Now, it really changes the game because, I mean, you could pretty much just put in forged pistons and you've got a forged engine. You've got a forged crank. Like, there's no real need to be going with a forged rod. I mean, obviously, everything has its limits, right? And I can tell you now, these rods can bend and break. And I've never seen these rods break because of an engine performance related matter, in the sense that they've made so much torque, you've bent the rod. I've never seen it. We've seen it with the S58 rods because they're shared from the S63s. But the reason why those rods typically bend is because those turbos are so torquey and so peaky that they can come on boost real early. So you put a lot of load on the Conrod in a low RPM, you bend the rod. Yes, they can withstand a fair amount of torque being a forged rod, but the way that a rod can handle torque, when you're at a lower RPM, it's harder for a Conrod to withstand forces than it would be at a higher RPM, because you've got your reciprocating mass and you've got all your compressive forces. A lot of things change based on RPM on what a Conrod can handle, particularly your rod bolts, right? Now, and this is interesting because, like I said, these Conrods are proving to be insane. And if we look at the rod bolt, the same rod bolt as the M20, they're the same rod bolt as the M55, they're the same rod bolt as the M54 from an E46, right? The rod bolts have not changed in a very long time. Even on the B48E, same rod bolt, right? That's the irony of it. The same, I think it's an M9 by 40 mil, right? Rod bolt. ARP bolts still exist. You can use the M54 ARP kits. I think they're even the M52s possibly are the same. I could be wrong on that. M54, 100% same bolt. Kind of insane. But it also goes to show that really, not to say that the bolt is not under stress, because obviously the bolt has got to keep the bottom of the cap together, right? But it just goes to show that the bolts really were not so much the problem. It was the design of the rod that really made the N20 rod weak, particularly because it wasn't a forged rod. The N55 eventually got a forged version of its Conrod, which is just insane. It's not really the bolts that's the problem with the N20, it is the rod design. Now with these, the fact that it's made using the same bolts, remove the bolts from the equation. The rod design is cooked. It is great. It is really good. It really means that when it comes to going to a forged, an upgraded Conrod, I would be doing it if we knew the limits. Like I said, we've seen 1,300 newton meters on a B58. We've seen 800 newton meters on the B48. I don't know when these break. Personally don't. I've scoured the internet to know when these break, and I cannot find information on when these break. I haven't even seen it happen, whether it's to my car or whether it's someone else's car, and I'm specifically referring to breakages because of power. I'm not referring to these breaking for any other means, and I'm going to explain why. For example, I've seen these break, rather be bent, because of hydrolocking. I don't know what Conrod wouldn't buckle when you try and hydrolock an engine. It's going to happen. It will happen. It definitely will happen, right? So I've seen these bend. Usually, when you hydrolock an engine, it's rare for the Conrod to bend. I'll try and do it for the camera. It's rare for the Conrod to bend sort of that way. So you get a buckle, right? Usually, when a Conrod bends from hydrolocking, it's bending this way or that way, right? So I've seen the rod bend. It's in the middle on these rods. I've seen them bend under hydrolocking. So it does a bit of this. I might try and chuck a photo up in the corner somewhere. The N20 rods were the same. Usually with an N20 rod, when they'll bend, they would usually start to bend about here, and usually they'd also pull away from the rod cap as well, and that's where the bolt stretch happened. And that would only happen if this had started to bend, because eventually the rod gets to the point where it's like, well, I've got to go somewhere. So I haven't seen these break outside of that. I've seen these break from engine failure, but usually, well, when I say usually, 9 out of 10 times, that engine failure is because the piston has let go and the Conrod's sitting in the cylinder going, well, I'm rotating at 3,000 RPM. Where would you like me to go? And then it starts hitting things, and it doesn't bend, it shatters, right? So I've seen these rods break like that, but I have not, under power, under torque, I've not yet seen these rods bend or break because of that. Usually the going factor is pistons. I think we all know that, to be honest. It's pretty well documented. Now, B48E rod. I don't know if you've noticed this. Can you see a difference in the Conrod? It's actually quite obvious. So let's talk about the differences. Number one, up the top on the small end, we no longer use a brass bushing in the Conrod. Why BMW did, I'm not exactly sure the science behind it, but it does allow, with the coated wrist pin, for a really cool low friction setup, right? It also means you're removing additional material from the small end. Now, when I say you're removing material, I'm going to be specific here. You're removing an additional foreign material. So what you can do is fill that with the same material of the patent object. So in this case, we can fill this now with all of it. It's all the same product. It's all the same material. We don't have a press fit brass bushing in here, which means we're using all of the same material. We're not using two different materials, because two different materials don't always play well together, right? There's also an added manufacturing cost. There's a few other things that come with it, right? It's the same with when you sleeve an engine. Yes, it works, and it can work really well, but at the end of the day, it's not all the same material. If you could make something that is all the same material, the thermal expansion would be the same, the way the tensile strength would all be the same, like the way it handles and distributes load, it would all be the same. There are so many benefits to having one of something rather than a few of something else. So I think it's going to come down to really the fact that with the B48E specifically, they obviously, the M division were like, hey, this engine's going to be running 24, 25 PSI boost around that. It's going to run some leaner AFRs than what you would have seen in the B48 TUs. It's on par with the S58. It's going to run S58 injectors. You know, we're going to run 9.5 to 1 compression pistons. Like, this thing's going to be, you know, a really kick-ass B48 out of the factory engine, right? I know some people are going to be like, oh, but it paired to a shit gearbox. I don't know. My gearbox hasn't broken, so, and I haven't seen a lot of documented cases on that, but anyway, that's for another video. Now, the engine with the B48 TU, I've only seen these rods listed ever to be in a B48E. Right? I have not seen these Conrods in any other engine. In fact, I measured it. We're talking millimeters of differences. It's actually not a lot, but I don't know why they would change the rod design when they've already got this design. Like, this is an added cost, particularly because it's going into a particular engine. Now, you could also argue, well, why they changed the crank then? To be fair, I think the crank change was a welcome change, and considering the N20 and B48s both run 50mm main journals, and the N55s, I think we're closer to 55mm, give or take. Don't hold me to that. I'm not looking at the documentation, and I can't memorize this stuff. B48 N20s, I can tell you about it all day, every day. But it's a welcome change, so I can understand the crank change. With the rod, it doesn't make a lot of sense. Now, obviously, the small end change is a welcome change. You can tell that they've obviously reduced material everywhere, which also adds to weight and allows for, you know, more responsive engine and all that sort of stuff, especially if you're lowering compression. That can reduce responsiveness of the engine. So if you can make the rotating assembly lighter and more responsive, then you can sort of make up for it, right? So we've got a difference, obviously, if you look up here in the small ends, there's more material on the Gen 1 / B48 TU Conrod up here than you do here. But then again, like I said, you've pushed in a brass fitting into here, a brass bushing, I guess you could call it. So they've added more material, parent material, to the Conrod to try and compensate for the fact they've got a different object in there, right? Now, obviously, the thickness of that brass bushing also plays into it as well. But on this, it's one uniform part. Now, because they've added the bushing, they've obviously widened all of this part of the small end, which means the cross section here is wider than on this rod, because they've had to allow for provisioning to push in this bushing, because it's obviously, you've got to take into effect that you need a brass bushing to be, you know, so many millimeters thick. We can measure it now if you'd like. You're looking at about, give or take, a millimeter thick, the brass bushing on this. Now, if we look at the internal diameter, because like I said, same 22mm wrist pin. We look at the thickness up the top. We're looking at about 4.5 mil, right? That's the thickness of the small end from internal diameter to outside external diameter. B48 Conrod. We are looking at about 4 millimeters, right? So it's 0.5 mil less thicker. Then we come down to top of the bottom of the spool and the top of the rod, right? Before the shank of the rod. We'll look at the width there, right? We're looking at about 23.5 mil, right? We look at this, right? A non-B48 rod, our B48TU, B58TU rod. 24.5 mil, so it's a mil thicker up the top here, right? Now, we look at the shank of the rod, okay? From top to bottom, like I said, top 24.5. And we go down to the bottom here, right where the big end is, roughly, because it's a bit of a hard science to try and measure this as accurately as I can. Roughly, we're looking at about 46 millimeters, give or take, if I can try and get that measurement as accurate as possible. Now, with the B48 Conrod, all right, we're looking at about, it's about the same, 48.5 mil. Now, you might go, well, that's a bit weird, because why is it the same down here, but it looks different, doesn't it? You look at that, you go, that looks wider. The B48, B58 rods look wider than the B48. That's weird. And you would say that's weird. Why would BMW make a weaker Conrod with an engine that comes out with more torque factory? Doesn't make sense, does it? No. And it also makes torque at 1700 RPMs. It makes 450 Newton meters at 1700 RPMs. That's insane. So, why is the Conrod different? Well, what I've noticed is that the ribbing here on the I-beam section of the shank of the rod, it's thicker than the ribbing of the B58, B48 rods. It's not a lot thicker. It comes in around about, and these are hard to measure because of the curved surfaces. It comes in around about, so the Gen 1s are, Gen 1, Gen 2s, they're looking at about 3.5 mil. Right? B48E, about 4.5 mil. Right? It's an extra millimeter thicker on the ribbing here. In terms of the thickness this way, that's 16 millimeters. And on this rod, it's 15.5 mil. Yeah, about 15.5 mil. Right, so it's a little bit thicker, you know, I guess this way. In terms of here, this is narrower. I will say it is narrower. We're looking at about 20.5 mil, right? Whereas here, now granted, this is also, you'll notice it's a bit of a triangle shape, right? It starts small and goes out large, whereas this doesn't do that as much. So if we do it in the middle of the rod, this is about 25.5, right? And I said this rod was 20. So the rod is thicker here by about 5 mil, 4.5 mil, right? Than the B48E in the middle of the rod. But they've added more material in here in the ribbing section. They've obviously reduced material here because they don't need extra material because they're not pushing in a bushing anymore. So they've saved some material there. It is a different texture and slight different metal composition over the Gen 1s. I don't know the exact composition of either, but I do know based on what I've seen in the documentation, it is an improved alloy and forging over the Gen 1s. I know the video keeps cutting it out. So yeah, it is a little bit different than the Gen 1s. But overall, I mean, you can even see they've added in, there's more material too around the bearing surface as well on the Conrod. So they've added some strength in there. In terms of capabilities of this rod, I mean, there's not a lot of tuned B48Es out there because most of those ECUs are locked. And then people complain about the gearbox, so they just don't tune it because they think the gearbox is going to break or something outlandish like that. So we don't know the true capabilities of this rod, but what I can say from my own experiences, I have run 600 Newton meters out of these rods and they haven't broken, right? So far pretty good. And that's a pretty good torque figure, all right? We're only 200 Newton meters off what these can run, what these have been known to run on the B48s. I wouldn't say that it would be worthwhile upgrading to this rod in any other B48, B58 because, again, we don't know what these are capable of. We know what these are capable of, so I'd say if you have these in your car, honestly, probably leave them and just change the piston if you want to go for big power. Now, from a B48 perspective, because I am a 4-cylinder guy, my opinion, right, when it comes to the B48 Gen 1s, 400 to 420 wheel horsepower on a dyno jet is a reasonably obtainable and fairly reliable number, right? Over 420, it becomes too risky. The cylinder heads on the B48 Gen 1s are not as volumetrically efficient as they could be compared to the Gen 2s, right? The Gen 2s have some better runner designs, a better runner length over the Gen 1s. They're just in general a lot more efficient head. The problem with that is that we then run into issues when it comes to things like boost pressure and everything else, right? The Gen 1s need more boost pressure to be able to get that air in because the cylinder head is a physical bottleneck when it comes to the efficiency of the engine, right? So porting that head would make for some good gains. It definitely would. Now, that means that when it comes to tuning those cars and getting them up to power, when you get over the 400 wheel horsepower mark on any B series engine, at the moment, you need port injection or you need to spend some serious money on some DI upgrades, right? Now, from the port injection front, if you don't have the port injection set up correctly, your window for error becomes very narrow. Very narrow. You can have one misfire because your fuel system, like your injector, can't handle it, right? Because your port injection, maybe it's delayed, it hasn't turned on properly, or it hasn't started on time, it's delayed by half a second, and that half a second is just enough for the DI injector to not be able to fuel that cylinder enough. You get a misfire. That misfire, that boost pressure, that ignition timing, the cylinder pressure in general, the power that it's making, it can be destructive, and it can crack your ring lands. It can do it. Any lag will do it. This engine, one of the cylinders was any lag, right? And for those of you out there that are aware of the fact that Kev, who set plenty of records on his B48 Gen 1 until the Piston was no more, we were getting so aggressive with our launch strategy because we were trying to go for such a good time. We opted to try out anti-lag. We knew the risks of it. We went and did anti-lag. It lasted 2 runs on anti-lag, and on the 3rd run, the spark plug absolutely shit itself, and that's why there is impregnation marks on this piston. The other piston, doesn't look as good. There's not much left of it because ceramic does not bust, compress, etc. So the piston shit itself. Look, we knew that risk. We knew that risk going into it. We knew on a setup like that what was the likely outcome of it, right? And we accepted those risks. With cars like Kev's, with cars like mine, we understand the risks that we're going to push the platforms in directions that a lot of others aren't, and we're okay with that risk. We would never on-forward that risk to an end user, right? And we go and do this to find out the limits. And sometimes you have to break an engine to know where its limits are. Ideally, if we can get around that, that's great. You know, I mean, you don't have to break every engine to find out its limits. And it's unfortunate that sometimes that has to happen, right? But it's called research and development. You know, it's just the nature of the game. So to know when a Conrod breaks, I mean, like I said, we still have not found an engine that has broken these rods. And you could try and build an engine to, or rather tune an engine to try and do it. But so far, not even me, but other tuners I've seen out there have not been able to throw these rods sidewards in the block. Very impressive Conrod design. So, yeah, unfortunately, sometimes, yes, you can break an engine. So, I know the story of this piston. I know where it came from. I know the exact engine it came from. It was an R&D engine, and that's why I have it. Would I recommend any lag on a stock piston? No, I would definitely not. Not even on the B48E. I wouldn't do it. I wouldn't do it. And I know, because I've seen what happens to it. I just wouldn't do it on a stock piston. Now, I know the B58 guys can get away with it to an extent. The benefits they do have is that there's less compressive load in each cylinder versus a 4-cylinder, and usually speaking, being an 11 compression B58, the 10.2s are obviously a little bit different again. Higher compressions do aid in turbo efficiency, do aid in spool up, and responsiveness in general. There's quite a lot of things that are different between 11, 12, 10 compression ratios. So, yes. I know the history with this one. Don't know the history of this piston. I know the history of this piston. So, B48E. I know the history of this piston. I'm going to talk about this briefly before we wrap up. This is a 2618 forged piston. This is an N20 N55 S55 Carrillo piston. Now, the reason why, I'm going to talk about this briefly, right? Some of you may even remember this piston. 2618 has a low silicon content, which means it expands more in the bore than a cast piston does, or a 4032 forging piston, right? Now, the reason why this is good is because think of it a bit like a sponge. It's softer material in its sense. It's not as hard, it's not as brittle, right? It's a little bit more malleable, it's a little bit more soft. So what does that mean? It means that it will take more detonation and it will take more abuse because it sort of reflects it, it rebounds it, it sort of, you know, it takes it and goes, oh, that tickled, and then it'll shoot it back out, right? It's the best way I can sort of analogize this. But these pistons are very forgiving. The problem with them, and which is why it's rare to see a manufacturer put 2618 pistons in a car, even the S58 is a 4032 forged piston, is because the cylinder wall clearance is not ideal. They can piston slap a lot when they're not up to temperature, so they do rock a bit in the bore when they're cold. And that's why with any engine that has these pistons, you need to get them up to temperature before you hammer the engine, because you will end up prematurely wearing the shit out of your pistons, because they will float in the bore. They'll rock, piston slap, because they have not expanded to fill the bore. That's why manufacturers rarely will use them, because the serviceability of these pistons, not ideal. 4032, on the other hand, pretty much takes all of the benefits of running a cast piston from a manufacturing point of view, and then just adds some strength to it, because the grain structure of a forged piston over cast piston is superior, because with the grain of a forged piston, the forged piston, they stamp it or press it into the shape that they need it to be, right? And you can get the grain structure to align how you need it to align. With a cast piston, you're literally liquefying that metal and pouring it into a mold, so you're hoping that that grain structure will just form, hopefully, in the best possible way it could form. And that's why you can have parts of the piston be weaker than others, or the overall piston to be weaker. So that's why there's inherent benefits between forged and cast, but 4032 would be more in line with a manufacturer might consider using if they don't consider using a high silicon content cast piston. Now, 4032s are high in silicon, which makes them harder, makes them brittle, but they're a little bit stronger than cast, but they are not very resistant to knock. Now, look, obviously no engine is absolutely immune to knock, right? They will suffer some damage depending on the type of knock it is. You know, the pressure wave that's being recorded, knock can be measured in a variety of ways. Knock is not just knock, you know, and I'm saying this in the sense that knock at different compression loads is going to be different, right? You can measure that to an extent depending on the type of measuring tools you have. Obviously, OEMs don't equip the car with anything more than a knock sensor and a few other bits and bobs, but the point I'm getting at here is that when it comes to knock, yes, a 4032 forging will survive it a little bit more than a cast will, but ultimately these things will take absolute abuse. They are the go-to piston material. Now, like I said, B48E has high silicon content because it is a high boosted engine, right? A bit like the S55, and your TU is a cast piston with a lower silicon content. It is still a hyper-ecratic piston, both of them are. This is just more hyper, right? And this would be a hypouratic piston because it's got less silicon, low silicon content. Right. Outside of that, with this B48 Conrod, the bottom rod cap, which I don't have on me, is basically all the same dimensions as the Gen 1s. There's no real differences there. It uses the same rod bolts. No differences there. Like I said, they are drop forged as well, so they're a cracked rod. So a cracked rod, the way that the rod caps mount up, they are unique to each rod, and they are unique to each side of each rod and each direction. So you can't put them on the wrong way because they won't seal back together properly. You have to put them back on the right way. So how they do that is they forge the rod all in one piece, and then they'll crack it, and that'll create the initial crack, right? That'll create the initial break point where the rod and the rod cap separate. And then you put it back together, you screw them in, and they'll basically, when they rejoin literally like as if they were one Conrod. I do have one. I have one that has the rod cap on it. Totally forgot. But if you look at that, you can, it's pretty hard to see. You can barely tell that there's a join at all in there. If it's not for, like, obviously these parts here, it's really hard to tell that there's a join. So that's sort of the benefit. So it's a better seal, pretty much. Forged rods will usually just be a machined surface. When I say forged, I mean aftermarket. That's usually just because it's an easier process for them to manufacture and create. Also, I'm just going to make a note with regards to some wrist pin stuff too. This is the CP Carrillo wrist pin, which they typically rate in a 4-cylinder application up to around 600 horsepower. Obviously, that's a bit of a vague number when it comes to rating components, because certain types of workloads will allow for a certain type of power on some components. Some components can handle, say, 1,000 horsepower in a drag application, but could only handle 400 horsepower in a rally application. So, as an average, apparently, the standard CP wrist pin on a 4-cylinder engine usually, right, and I say standard, I'm referring to the 22mm outside diameter, right, and a 12.75 millimeter internal diameter wrist pin, right? Usually these are good for about 600 horsepower. Anything over that, you need to go with the thicker ones. Now, the thicker ones, the steel ones, blah, blah, blah. Obviously, material matters too, right? So material composition does matter with the wrist pin. I couldn't tell you these, but I know the upgraded ones are a steel wrist pin and they are thicker. When I say thicker, they've got a smaller internal diameter. Now, for memory, the last time I measured it, I think it was around about 10 millimeters on the internal diameter, but the same 22mm outside. Comparing that to the B48s. Now, like I said, material composition matters, and these wrist pins from factory are pretty dope. 12 point. It's coming about 12.4. It's a bit hard to get a good measurement on it, but 12.4 mil internal diameter on the Gen 1/TU wrist pins, and then it's the same, 12.4 mil. So the thickness between Gen 1, B48, etc., they're all the same, except for the fact that this wrist pin has a coating on the outside of it. So these have a little bit more material thickness on the inside than they do the Carrillos. Obviously, like I said, material composition matters, but if we wanted to spitball an idea, it's possible that these wrist pins might start seeing issues on a 4-cylinder application. The BMW ones might see an issue over 600 horsepower, and that's where you might want to look to like a steel upgraded wrist pin. But then again, if you're going to be changing the pistons, you're usually changing the wrist pin, usually speaking. And this is specific to the B48E guys. If you wanted to retain the factory Conrod and you wanted to change the piston out, unless you're using the factory wrist pin, you can't use an aftermarket wrist pin, because you need to ensure you have that special coating on the wrist pin for the rod, because there's no bushing in the rod, right? So that's a big consideration to make if you were to try and retain the factory Conrods, is to retain the factory wrist pin, which means you need to have a piston that supports the factory wrist pin. But like I said, 22mm, pretty standard. I mean, this is the same. I mean, it fits inside a CP N20 N55 piston because it's the same external diameter, 22mm. All right. I understand we also haven't touched really on the piston rings and their type. I couldn't find any decent information regarding the type of piston rings they are. Like, you know, chromoly rings and all that sort of jazz. I couldn't really find out what type of piston rings they are. But so they seem to be the same set of piston rings with regard to the B48TU. Those piston rings seem to be found in other B48TUs, and they also seem to be found in the B48 Gen 1s. The B48E piston rings are not the same. According to part numbers, they're not the same. So it's likely that they are also a different type of material as well. Maybe they've even got a different ring gap, and that might be just to try and aid and give them a bit more breathing room when they're under power. So it's possible maybe they're the same material, they're just differently gapped rings. Aside from that, that is everything for today's video. I hope that it has maybe taught something. I tried not to get too technical, and I tried not to get too vague, but I wanted to discuss the differences between all of the generations of pistons, B48, B58, etc. And then I wanted to obviously discuss the differences with the Conrod as well. When it comes to the B48TU, because I know we just discussed, you know, obviously the risks you have with running over 420 wheel horsepower in a B48 Gen 1. With the B48TU, up to 500 seems to be pretty reliable from what we've seen, right? They're a pretty robust setup. We've seen results over 500. I would err on the side of caution about how reliable that may be at this time. There is not enough data to support how reliable over 500 will be. Yes, you can do it. Yes, we've done it. But you just have to be careful, because it's just unknown territory at this time. But up to 500 has been proven to be pretty damn reliable day in, day out on the B48TUs. With the B48Es, given they're a better piston design and or just an overall better piston and their lower compression, they will take more, but we have not yet seen what that more might be. It might be that they're reliable between 500 and 550. I don't know, and I think the problem we have is that, look, like I said, I haven't had gearbox problems or driveline problems in my car, but no one has really been willing, obviously, to test that outside of myself. But the other problem is too is that BMW equipped this engine, a really good engine, in a series of cars that didn't make a lot of sense. It would have made sense for them to put that engine in the Supra as well, and they didn't put it in the Supra. I'm not particularly sure why. It would have made sense for them to put that in, like, I don't know, maybe a car that was rear-wheel drive, not a front-wheel drive biased Mini Cooper with a glorified BMW badge on it. I'm not sure, but it does limit or restrict our ability. Now, it's interesting too. The newer B48Es is a new revision coming of the B48Es. They've already been released on the new X1 35i, M35i, and then the incoming revised X2 M35i. Now, the X1 is a rear-wheel drive only. I'm pretty sure it's rear-wheel drive. I have to double check on that, but it is definitely single axle. It's not dual axle, so it's definitely not an all-wheel drive car. The X2 is an all-wheel drive car, but both cars run the same gearbox. They run a 7-speed DCT. Now, the X2 M235 or 335i, it ran the same 8-speed AC gearbox as the Mini Cooper, JCW, Countryman, all four, the GP, F56, the M135, the M235, ran the same 8-speed AC gearbox. On the new ones now, I think it's probably more to do with the fact that they're an SUV. They've opted for the DCT 7-speed. I think it's the Jet Drag DCT. But, interesting, they have reduced the torque in that car. That torque for the new B48E is 400 Newton meters instead of 450. But it is also making 233 kilowatts versus the 225. So about 315 horsepower, right? Wheel horsepower. They bumped it up over the 302 or 306, right? So there's about a 10 to 15 horsepower improvement. But they've dropped 50 Newton meters of torque. Now, I'd presume that's probably more to do with the fact that the gearbox in those cars is probably not as capable as the prior gearbox. It wouldn't make a lot of sense for them to drop torque. Obviously, they bump power, which is great, but we all know at the end of the day, from a quarter-mile time, everything matters. Now, there is a refresh coming of the M135, so it'll be interesting to see what configuration they go with on that and why they've gone with it. Now, I have a feeling they've changed nothing with the hardware. Why they would drop torque, I don't think is due to the rod design. That's the reason why I brought it up. I don't believe it's anything to do with the rod design at all, whilst it does look a little bit weaker in some spots compared to this. But it does also show some improvements in other areas of the rods that this one does not have. I don't think it's got anything to do with that. Like I said, I still haven't even seen these bend. I've run 600 Newton meters, and I've run it for a long time. I've run it about 12 months. I've pretty much abused launch control and the absolute shit out of that car. So I don't believe it's to do with that. I have a feeling it's more to do with the gearbox choice on that car. But that sums it up for today's video. I hope it has been somewhat educational and helpful, and I'll catch you all in my next video, which I'll be talking about a overall update. We'll run through some stuff with my 135.